Okay. So that's what this chapter is all about. It's about data. Database, doing stuff with that data that we've been collecting for all these years. Because that's what we did as corporations for a long period of time. We captured all that transaction data, but we didn't know what to do with it. And they started over the last few years realizing that that data is really valuable. We can make decisions. We can make better decisions if we use that data properly. So that's what this chapter is about, is trying to figure out ways to organize that data in ways to be able to use it. So this chapter, learning objectives, describe how the problems of managing data resources in a traditional file environment are solved by a database management system. So we'll talk about some of those old file-based systems and how they kind of did things and what the problems were with those. We'll talk about the capabilities and value of a database management system, some of those problems that it fixes, and we'll talk about that. Apply important database design principles. We're going to hit those at kind of a high level. I don't expect you to really know in detail things about databases. This isn't a database class. So I'm just going to talk about those at a relatively high level, so don't worry about that too much. Evaluate tools and technologies for accessing information from databases to improve business performance and decision making. So we'll talk about some of those tools that people can use to be able to make better decisions. Again, this class isn't about those tools per se, but we should be able to point you in the right direction, that if you are running a business and you do have this massive amount of data and you want to be able to make decisions on it, you should be able to, after this chapter, understand what some of the things are that you need to learn more about to be able to take advantage of that. And assess the role of information policy, data administration, and data quality assurance in the management of a firm's data resources. Answers that you get from your data really hinge on the quality of your data. And so if you're constantly putting bad data into your database, you're not going to get very good answers. And so that's what that last bullet point is talking about, is how do you make sure that you've got good data in that database. So it starts out with the case example, like it does in each chapter. It talks about the explosive growth created information management challenges for R.R. Donnelley, which is a paper company. A company that produces a lot of things, books and things like that. And it helps to illustrate, I think, the point that we see in smaller businesses or older businesses, ones that have not gone through rapid periods of growth, but rather have grown larger and larger and larger over a longer period of time, that as a business has done that, what's traditionally happened is those information systems that we've talked about have developed independently. Manufacturing has developed one. Sales has developed their information system. Human resources has developed their information system. And it took years for the problems that come from having those separate systems to actually show up and be able to identify those problems. When you have a situation of mergers and acquisitions occur, you can see that what took place over several years for one business occur virtually overnight for this type of business, because now they're having to merge different systems from two different businesses. They may have different systems in place, they may have competing systems in place, but they don't look at the same data. So they may look at a customer, for example, and some of the fields that are in the databases, in one database it may say last name for a customer's last name. In another, in the other company, it may say L name or something like that. It makes it hard for a program to be able to access a field when it's trying to access it by name, and the names are different. The field names are different. It's a problem. It's a problem. It makes things difficult. So they talk about the use of master data management. It's a company that has this software that basically acts as middleware. Allows you to kind of put together disparate systems and allows them to talk to each other and allows them to clean up the data so that you have this singular view of data from all your various information systems. And so they talk about it being a good success, that it demonstrates IT's role in a successful data management. And it illustrates digital technology's role in storing and organizing data. It allows you to make sure that you've got that high quality data. Again, if you've got all that data and you're not using it, you're not going to get any benefit from it. If the data's bad, you're not getting any benefit either. So before we get into it too much, the chapter starts out talking about different ways to look at data, different ways to look at information. And they threw up this slide, and I didn't really care for that one. I liked their next slide, which I think goes into a little bit more detail, but I think it helps to illustrate it a little bit better. And like most things in life, I want to start out with the answer, start out with the bottom part first. It starts out with a bit. That's the smallest piece of data that we can have in a computer. Zeros and ones, that's what a computer does. So a single bit, a single number, either a 0 or a 1, that's a bit. That doesn't tell us much. That tells us on, that tells us off. That tells us 1, that tells us 0. That's all it can tell us. So we really need to focus on that. We need to be able to combine that into multiple bits to be able to give us a little bit more information. If we put 8 bits together, we end up with a byte, and that gives us a little bit more information. A byte now can start to represent larger numbers, can start to represent the alphabet, and in this case, that's exactly what we're doing here. It's a letter, is it 1? Or I think it's the letter 1. If we start to combine multiple bytes, now all of a sudden we can represent words, or a field, if you will, if we were talking about a database. So we could represent a course number, in this particular case, IS, in our case, 511. If we start to combine multiple fields, we can get a little bit more information. Now we can have a record. We can have information like a student ID, course number, the date or semester, a grade. So we can start to get an idea of what that record is about. It's about somebody's grade in a particular course in the semester that it was taken. We can start to combine multiple records. And now we've got a file or a table, if we're talking about databases, because it's multiple students. They're all related. Multiple records inside of that table. The database is multiple tables, multiple files together that are all related in some fashion. So over here we may have a financial file. Students have paid for their classes. They owe a certain amount for their classes, things like that. Personal file, their permanent mailing address, their campus mailing address, phone numbers, email addresses, that type of information. And then the course file, what courses have they taken, what courses do they still need to take for their degree plan and things like that. So you can see in a student database, all the various tables or all the various files are related to each other. Keep in mind that term related. We'll get back to that here in a little bit. So going back, that's kind of what they're talking about here. They're kind of giving you the reverse of it. They're starting at the top of the database and working their way down. Now, I wanted to go back to it a little bit because there's a couple of pieces down here that are kind of important when we talk about databases. There's the concept of an attribute, there's the concept of an entity, and this concept of fields. Now, some people will say that an attribute, well, let's start off with entity. Entity is something that we want to know something about. So an entity is probably going to be a table. It's going to be a file. It's going to be a person. It might be a student, for example. We want to know their name. We want to know their permanent mailing address. We want to know their degree that they've signed up for, what they're working towards. An attribute are those individual things. It's what their name is. It's the name. It's the address. It's things about the entity that we want to know about. So an attribute and a field sometimes are referred to interchangeably, depending on who you're talking to. Okay, so those are some of the basics when we start talking about data and the relationships between the different pieces of data. With a traditional file-based environment or file-based system, it works fine in a small organization. It works fine in a situation where you don't have a lot of data that's being gathered. What happens in a file-based environment, though, is over time that file begins to fill up. It gets larger and larger and larger. Well, what happens if you've got more and more things to look for? If you've got a specific record you want to look for, and you've got 2 sheets, it's usually 2 sheets of paper, and each piece represents a record. If you've got 2 sheets, it's pretty easy to find that record. If you've got 10,000 and you've got to find one specific sheet, it's a little bit more difficult. So that's one of the problems with a file-based environment. There's others as well. There's another problem that refers to the fact that in a file-based environment that you have a linkage between the program and the data itself. So there's this inability to separate the program from the data. The reason that's a problem is if you make a change to the program, you've got to make a change to the data. Or if you've got to add a piece of data, you've got to make a change to the program. So it's a problem in terms of maintenance, maintaining maintaining your database, your file. So there's a number of other problems as well. Data redundancy, data inconsistency. In a file-based system, when you have for example, you have a customer that comes back in and wants to make another purchase, or you have a student that wants to register for another class, you have to enter all that information in again. The customer name, customer address, customer phone number, all that stuff again. So that leads to data redundancy. What's the problem with data redundancy? There's a couple of big ones that should come to mind. Anybody?
You can double count results, so your metrics are off.
That's not quite what I was going for, but yeah, that's a possibility depending on how your reporting functions work. You could be counting things multiple times. Space is a big one. That's one of the ones I was looking for. If you're counting everything more than once, you're taking up that much more space. Whatever that field is that you're repeating, it takes up for every record that's repeated, you take up that much more space on in your storage. Now again, storage is relatively cheap. We've talked about that. That's not a huge deal anymore. But again, if you're GM and you've got 10,000, 100,000, a million records, even a small amount of space duplicated can add up. The other thing is errors. If you type it in more than once, if people type in my name more than once, my last name, I guarantee you they get it wrong. They do. So now, going back to your reporting thing, now you've got two records with two different H.Schuesslers spelled different ways. You ever get stuff in the mail with your last name on it that's misspelled? You get it twice. You get once the correct way and once the wrong way because you got put in the database twice. So data redundancy, data inconsistency, and then that program data dependence thing that I was talking about. That program data dependency leads to lack of flexibility, leads to poor security, leads to lack of data sharing issues. So then they kind of throw this one out there, and I wasn't a big fan of the graphic either. But so database approach is a little bit more modern approach, and I say a little bit more modern because it's not like databases just popped up last week. They've been around quite a while now at this point. I think the relational database actually was put out designed by a guy named Chen. I think he worked for IBM back in the 70s for the relational database model. When I say relational database, there's a lot of different types of databases. This chapter talks about two different types of databases, a relational database and an object-oriented database. But there's a lot of other types of databases that are out there. Those are the two most common. By far the most common is relational, so that's the one we'll spend most of the time talking about. A database serves many applications by centralizing data and controlling redundant data. When they say centralizing data, I think what I really would have liked to have seen them say was not only centralize it, but separate it. Databases separate the program from the data itself. So with a database, you can have multiple applications accessing that same data. So you can have a web application that accesses that data. You can have a program on your computer that accesses that data. You can have a program for your iPhones that access that data. And it all comes from the same database. So there's a consistency from the data no matter where you view it from. So it separates that data and allows you to centralize it. It allows you, assuming you do it properly, allows you to reduce redundant data. You're never going to eliminate redundant data, but you can reduce it substantially, and that's a big deal in terms of storage and in terms of having consistency. Most of the time, we don't do anything with the database itself. We can't access it. We don't access it directly anyway. We use what's referred to as the database management system to access the data, and that's what we're dealing with. The database management system manipulates the database. We manipulate the database management system. When I say manipulate, it allows us to create tables. It allows us, which are those entities, the student, the class, things like that. It allows us to create those attributes. The database management system does. It allows us to create the relationships between various tables, and it allows us to do maintenance functions, deleting records, backing up the database, restoring the database, things like that. So you might look at a database kind of like that. Here's your overall database. You can use the database management system to pull data out in forms that you need. So you may have, for example, over here, you may have the need for a view of the benefits. So you don't have to pull everything out of the database to be able to look at that. You can just look at the information that you need. In this case, name, social security number, and health care. So whatever plans they happen to be signed up for. But you may have a need for other people to have access to payroll data. They don't need the same information. They need name and social security, but they don't need anything about the health care. They need gross pay, net pay, things like that. So you can separate that data. The advantage of that, better privacy, better security. Like I said earlier, the most common type of database is the relational database. People are used to it. It's been around for a long time. It's very well understood. There's lots of development techniques. It just makes a lot of sense in most situations to use a relational database. In fact, if you talk to most people that aren't real hardcore database people, that is the only type of database that exists. Represents data as two-dimensional tables called relations, files, or tables. Each table contains data on an entity and its attributes. So if you look at the table, across the top you've got your various fields or attributes. Name, address, phone number, etc. The records are represented down as far as rows. They go down. Every time you add a record, it's added to the bottom. So the table is a grid of columns and rows. Rows are sometimes referred to as tuples. Don't get too caught up in the terminology. Nobody calls them tuples anymore, but that is what they have been referred to traditionally. So those represent records for different entities. Fields are also sometimes called columns. That really does depend on who you're talking to and how they'll refer to it. Represents an attribute for an entity. So something about that entity. You know, the color or name or whatever. A key field, and they talk about it at a very rudimentary level in the text. A key is something that's unique in some way. Now, they kind of give you a little bit of a misnomer here, a little bit. A key in general is something unique about that row. The idea is that they want to then talk a little bit more in more detail about the primary key, and that's where they're really starting to focus in on what you need to know. Primary key is something that's unique about that specific record. If you look up that primary key, you're not going to get any other record in that table. There are no duplicates of the primary key. It's never repeated. You may have a repeat of some other field, and we want to try to reduce that as much as we can, but the key to a relational database is this primary key and the foreign key. The foreign key does get repeated over and over again, at least hopefully if you're in sales. So you may have a couple of tables. That's what these next two slides are about. This one is a table on suppliers. So you'll look here, you should see a couple of things. You get your various attributes up here at the top. Supplier number, supplier name, supplier street. Things that are associated with what? Supplier. So when you start to see things that are associated with one thing, that's a table, that's an entity. So, and then these are the various attributes. The supplier number is something that's unique each and every time. It's always going to be unique. You may have a duplication for some reason here, name, supplier street, hopefully not. But say, for example, you've got CBM Inc. has 2 locations. Maybe you happen to have a duplication. You've got a different supplier number for the second one, but you might have the same supplier name, a different address, different city, depending on how it happens to work. Now the part table should look a little bit different. Again, everything's associated with parts in some fashion. So even though your attributes may or may not actually say part name, part number, part name, things like that, if it's associated with that, they're all part of that entity. So with respect to parts, you see the same thing. These various part numbers, all primary key, all unique, all different. What is a little bit different is over here on the right. You've got the supplier number. The supplier number is the foreign key in this table. It's the child table in this relationship. So in this particular case, we have a duplicate, 8259, 8259. This part and this part well, and this part up here, are all associated with that specific supplier. 8259, CBM Inc. That's where those parts come from. That's the relationship side of things. Now, there is something wrong with this design. Well, I say there's something wrong with it. There's something wrong with this design only if you never, ever, ever get the same part from more than one supplier. If that's the way your industry or your particular business works, then that's fine. But in a lot of cases, you can get the same part from multiple places. If that's the case, that's a problem in the database design. You'd have to redesign the database. But that's how the foreign key part of it works. Now, operations of a relational database, there's actually a number of different ones. These are some of the common ones, specifically the real common ones, joins and selects, but you've also got projects as well. So the basic idea of, or basic operations, select, creating some kind of a subset from the database. So you want to select only certain suppliers, maybe only suppliers from a certain city. You can do that with the select statement. You can do a join, which combines relational tables to provide user with more information than available in individual tables. So maybe you want to look up a couple of parts from these suppliers. So you can do a join. You have to have both tables to be able to get that information out of the database. And then you can do a project, which creates a subset of the columns. Maybe you don't want all the information from the supplier column, or all the information from the supplier table, or all the information from the parts table. Maybe you just want the supplier name and phone number. You don't need their address. You don't care about their city. So you don't need all those attributes. So if you combine all three of those, the three types of queries, a select, join, and project, you can end up with this type of information. So they end up looking up this part for part number 137 or 150. They want to know part name, supplier number, and supplier name, but they don't want this other information. They don't want the unit price. They don't want the address of the supplier. So they're only getting back the information that they want. And you can customize that however it is you want. That's the beauty of databases. Another type of database that's relatively new that is becoming more popular because of the popularity of multimedia that's all around us anymore. Object-oriented databases. Object-oriented databases handle those multimedia files much better than a relational database does, because it's designed to deal with things like pictures, movies, songs, things like that. So it does much better. It's relatively slow compared to a relational database management system. So if you're trying to crunch numbers, if you're trying to run reports, you're trying to process transactions and determine, what the sales figures are in a region or something like that, an object-oriented database probably isn't the best approach. As a result, you end up with some of these hybrid object-oriented relational databases that kind of try to combine the features of both. And it gives you some of the benefits of having a relational database and the ability to handle different types of objects. Then you've got databases in the cloud. It's not something that's really taken off for the most part. Again, it has to do with a number of things. Performance for one, putting all your data out in the responsibility of somebody else bugs a lot of people as well. And in some cases, the feature set just isn't as rich as having your own database. You don't have as many things that you can do in terms of manipulating the reports or forms and things like that you can or can't create. Capabilities of database management systems. Any questions so far? How are we doing? Okay. Data definition capability, data dictionary, data manipulation language. Data definition capability specifies structure of database content used to create tables, define characteristics of fields, things like that. So now we're just talking about the tables, and it takes care of this stuff for you. The database management system does, so you don't have to worry about this stuff. The data dictionary, automated or manual files storing definitions of data elements and their characteristics. So stuff that you get to kind of customize in terms of how wide is this field going to be? Is it required or not required? Things like that. And then perhaps more importantly, SQL, the data manipulation language. That is something that you tend to have more interaction with as a user. In some cases, you don't have to understand SQL directly. There's a lot of wizards, for example, that will create a lot of the SQL for you in a lot of cases. But if you're going to be a database administrator, if you're going to work with databases, and I would always encourage anybody to do that because database administrators make a ton of money. But you really should learn SQL. SQL is one of those things, if you use one of those wizards and you're not getting the results exactly what you want, by understanding SQL, a lot of times you can look at what the wizard has produced and identify the problem there, and you can modify the SQL yourself and get the report or whatever it is, the query that you're trying to create, taken care of. Like I was saying a second ago, many database management systems have report generation capabilities for creating polished reports. Crystal reports is an example. Microsoft Access has its own stuff built in. You can actually use Crystal reports with that as well, but it has a lot of that stuff built into it, wizards that are built into it. So by all means, take advantage of it. So the database, Microsoft Access data dictionary features. You can see, you can create your various attributes right here, and you can identify the data type. Is it going to be text? Is it going to be an auto number? Auto number is important because you look at the very top of that, right next to it, it's kind of hard to see probably in the back. It's a little key. That's your primary key. It's an automatically generated number. Every time a new record is added to that table, the number is incremented. You always have a unique record. So you don't have to maintain that as a user. You can create your own attributes, the data types, text, you can make a number, things like that. And then a description. The description isn't required, but it helps people. And then you've got stuff down here that really gives you a lot of control over a specific attribute. So for supplier name here, we can define the field size. How much space do we want to allow them to use to take up for that attribute? In this case, they set it for 50. You can use input masks if you have a specific mask. Usually it wouldn't apply to something like supplier name, but let's say you were storing somebody's phone number or their social security number. We as people have we've got this visual idea of what that should look like with respect to the dashes and the numbers. We can create that input mask and create that there. We can have default values. We can validate the text. So there's a lot of things that we can force onto the data as a user's inputting a record. The reason that's important is what we'll talk about at the end of the class. Having that good data go into our database, making sure that we have data that meets certain criteria before it's entered into our database. Validating our data, making sure that the phone number has all the digits before it allows you to exit that record or save that record. So here's an example of an SQL query. Anybody tell me what that query is saying? Take a stab at it.
Select part, you get the number, the name, supplier,
Supplier number.
and it's between 137 and 150.
Yeah, SQL is pretty, it actually is fairly forgiving for a programming language. It is probably, a lot of people would refer to it as a high-level programming language because you can not understand SQL and look at it and say, I kind of know what's going on. Because that's exactly what's happening. You're selecting, excuse me, you're selecting from the part table, part number. You're also selecting from the part table, part name. You're also selecting from the supplier table, supplier number, etc. Now you have to include the actual, even though you've identified the tables here, you actually have to say from the part table and the supplier table. And here's your condition, where the part supplier, this is your join that's occurring right here, where the supplier number in the part table equals the supplier number in the supplier table. So that's the join between those two records that's going on. And then this is the last piece of information that you need. You're wanting to limit it to those two parts. Only those parts that are 137 with part number 137 or 150. So you're getting back just the results. That's the query that we were showing earlier. That's the actual SQL for it. Now I mentioned that Access has wizards built into it. You don't have to know SQL to be able to generate that query, that SQL content in Access. You can pull up this screen in in Access and have the same thing. You include these two tables. You can make your selection. You want part number from the part table, and you want that part number to be between the criteria here is between 137 or 150. You want the part name from the part table. You want supplier from the supplier number, or supplier number from the supplier table, and the supplier name from the supplier table. Something else they don't really talk about, but I wanted to point out up here, you see a relation up here too between these two. And we kind of talked about it when we talked about the tables. You see this relationship between the supplier number, there's the supplier number over here, which is the primary key in the supplier table, and the supplier number in the part table. That's what's linking them together. But what I wanted to point out was this, what you see right here. That's a 1, and then down here you see an infinity sign. Any idea what that means? It says there's a one-to-many relationship between these two tables. It means this one supplier can provide lots of parts. But this part, whatever specific part we happen to be looking at, can come from one and only one supplier. That was the problem that I was talking about earlier. If you can get that part from more than one supplier, you really kind of have to have a different part number associated with it. So that could lead to a problem. So designing databases to fix problems like that. You've got a couple of different perspectives. You've got a conceptual or logical design, and you've got the physical design. The conceptual design is an abstract model from business perspective. That's what database designers are going to create. They're going to come into an organization. They're going to look at the various things that you have going on in that organization. They're going to ask you for the reports that you generate. They're going to ask you to look at your existing system to get an idea of the different pieces of data that you use. They're going to talk to various people throughout the organization and ask them, what do you want to see? How do you want to see things on the screen? Things like that. And they're going to come up with a conceptual design. And then you end up with a physical design. People are sitting down and actually coding the actual database itself, what actually gets implemented. Sometimes, for the most part, you would hope the two end up pretty close to each other, but the reality is they don't always. Design process identifies relationships among data elements and redundant database elements. You're going to have some redundancy no matter what, and some of that's not necessarily a bad thing. Too much of it is. It's also going to find the most efficient way to group data elements to meet business requirements and the needs of application programs. In order to reduce that redundancy that occurs, we go through a process called normalization, and that's a process of looking at an entity and identifying opportunities for redundancy and figuring out ways to eliminate that possibility. So if we take a table like this, or an entity like an order entity, we can look at this information, and they do a good, one of the things that I really like the way they do is they're trying to really show you graphically what's going on in terms of what should some of the entities be. If you look at, because a lot of times what you would see here is you'd just see number, you'd see date, you'd see maybe part number. But if you look at this, you see order number, you see order date, you see part number, part name, part quantity, supplier number, supplier name. So you see the beginnings of each one of those should give you a real clue that maybe those should be separate entities. In fact, that's what they do once they go through the normalization process. They say all those ones with part have their own entity. I do have a supplier number here, and that's what? Foreign key. That's to tie things back together. That would be the same number as this primary key on the supplier table. So you see all these associated with supplier. You see the line item over here, which is a little bit different, and then you see a separate order. It's kind of interesting. Order is just has two fields in it now. And one of those is the primary key. So once you do this, what happens is you end up with a supplier who provides a part, and with this order, you've got multiple line items. So this line item is going to be associated with one or more orders. So you can end up with some redundancy in terms of your line items being repeated over and over again. Because on a ticket, hopefully you got people ordering more than one thing. That's what you want. But by separating this out, what we're really going to be repeating over and over again is really nothing more than those keys, those foreign keys. That's what's going to be repeated over and over again. We can handle that programmatically. What do I mean by that?
They can remember and fill that in for you so you don't have to rekey it every time.
The computer fills that in. We don't do that. That's important because people make mistakes, lots of mistakes. We key things in wrong. We misread things. Computers shouldn't make mistakes. I say they shouldn't. Computers actually don't. Designs, human-made designs do. But, so it eliminates the possibility or the likelihood of a lot of those key mistakes. So that's, are we eliminating all the redundancy? No, but we are eliminating a lot of it, and the redundancy that still exists is very controlled. The entity relationship diagram is what allows us to start to model these relationships. And after somebody that's a database designer has gone in and talked to the people that are in that organization and identified these various entities, these various attributes, they can start to model how the relationship between those entities and attributes using an ER diagram. So it illustrates some of those relationships. They don't talk about this in the text. It is kind of an important concept, so I did want to kind of touch on it briefly, but they didn't. I don't remember that being touched on in the text anywhere. They talk about this idea of distributed databases and storing databases in more than one place. There's a couple of reasons you want to do that. One of the big concepts in terms of data is that you want to locate data as close to users as you can. The reason you do that is access. It's faster, it doesn't use as much network resources if it's closer. So you want to locate that data as close to users as you can. You get better response. Another advantage to distributing your database is if there's a problem in one part of your network, a problem in one part of your database, it doesn't affect the rest of your data. So that's you're reducing your risk by doing that. To do that, one of the ways to do that is partitioning, and you can partition databases in a number of different ways. You could separate tables into maybe some in New York and some in Los Angeles. You can partition it in terms of records. Maybe you only have records associated with the East in New York and only the ones associated with the West in Los Angeles. There's different ways to partition your data, but that's what they refer to is partitioning your data when they talk about that. What happens when you split your database up, once you partition your database up though, you do have this issue of replicating it though. You periodically have to make sure there's consistency in your database. That's what replication is all about, is making sure that eventually those differences that you have between your two locations get meshed back together for reporting purposes. Somebody eventually wants to know what your total sales figures are, not just what the sales figures are in the East and West. So the ER diagram might look something like this. Over here we've got an order, and we've got a couple of hash marks, and I'll get back to that in just a second. And then we've got a line item, and what's referred to as one hash mark and a crow's foot. What that means is that for this order, this line item is associated with this order and only this order. It can't be associated with any other order. But this order can have one or more line items, and hopefully lots more if you're in sales. This line item can be associated with one and only one part. If we're going to list a part on a line item, we're only going to list that one part. We can't list multiple parts on that one line. We want multiple lines, but we only want one part listed on that line. But that part can be listed on lots of lines. Maybe on more lines for this order, on other orders as well. And then this part can be associated the way they have it modeled. I'm not saying it's right, but the way they have it modeled. This part is supplied by one and only one supplier. It's the only place we can get it. But that supplier supplies us with multiple parts, a door, a latch, a window, whatever. Very large databases and systems require special capabilities and tools to be able to analyze lots of data. When this data gets larger and larger and larger, it gets really hard to look at. And if you read through the chapter, there's a couple of examples where some organizations are trying to analyze some of this data by hand. They're trying to look at a subset of responses, for example, and get an overall picture of what's going on. And certainly that gives you, it's better than no idea of what's going on, but it's not really a complete picture by doing it that way. They also allow you to access data from multiple systems. 3 key techniques that you can use: data warehousing, data mining, and tools for accessing internal databases through the web. So a data warehouse is a massive warehouse. And they don't talk about it in the book as well as I would like for them to. They talk about it storing current and historical data. Historical data is true. When they say current, there's a disconnect between a data warehouse and your transactional database. So when they say current, it may not be completely current. It may be a day old, it may be 6 months old. So their idea of current may not be current. But the idea is that it's offline. So it's separate of your transactional database. So it allows you as an analyst to go into that data and really play with it and not have to worry about affecting your daily operations. One of the advantages of a data warehouse: it consolidates and standardizes information for use across the enterprise, but the data cannot be altered. That depends on the data warehouse as to whether or not it can be altered. But it does store a lot of information from across the organization, and that's an important concept. It's separate of a data mart, which stores information related to just certain areas within the business. A data warehouse spans the entire organization and potentially pulls information from outside the organization. Maybe information from the Bureau of Labor Statistics. Maybe information about the weather, depending if you're doing a data warehouse that involves global climate change or something like that. So it can pull information from a lot of different places and allows you to put it all in one place so you can analyze it. Data warehouse system will provide query analysis and reporting tools, so ways to extract information, ways to present that information, ways to ask it questions. Data marts are similar to a data warehouse. They're smaller in scope. They're more narrowly focused. They may focus on a marketing issue, for example, or production, something like that. Sometimes a smaller organization will take a data mart approach because they don't have the money for a data warehouse. Data warehouses are much larger, more expensive. So in a lot of cases, data marts end up getting used because the problems that they're facing are a little bit smaller, and it costs too much for a data warehouse approach. So you might see something like that. Various systems inside of an organization. A data warehouse will allow you to extract information from those different parts. So from operational data, customer data, manufacturing, things like that, and potentially from external sources, and allows you to look at that data, ask that data questions, and report that data in various formats, different types of forms, depending on how you need it. Now, hopefully the information we get out of that, or the reason we want to get information out of that, is business intelligence. And if you've watched the industry over the last few years, it's a big buzzword that you hear a lot. I don't know how much of a buzzword it is now versus what it, using your data has been in the past, but business intelligence, tools for consolidating, analyzing, and providing access to vast amounts of data to help users make better business decisions. That's what we want to be able to use that data for. We've been acquiring all that data. What can we do with it? What does it help us do better? Hopefully make better business decisions. The example in the book, they talk about Harrah's. Harrah's using data, business intelligence tools to be able to identify customers, customers that are going to spend more money with them, customers that are going to gamble more, contribute more to Harrah's bottom line. So they can segment their customers more. They know who to cater to. So it costs them less to get more out of you. Principal tools include software for database query and reporting, OLAP, and data mining. So OLAP supports multi-dimensional data analysis. So if we want something that's a little bit more complicated than just what are my sales, last month, we can use something like this. It allows us to look at multiple dimensions, not just a time period, not just sales, for example, or last month. Each aspect of information, products, pricing, cost, region, time period, all of those can represent a different dimension. In fact, the example they give us here in just a second gives us a cube. But using OLAP, you can actually create multiple dimensions or many more dimensions than you can visualize, and you can draw on a piece of paper. So you can make some very complex comparisons if you want to do that. So the example they use is how many washers sold in the East in June compared with other regions. OLAP enables rapid online answers to ad hoc queries. So they give us this cube here, and one of our dimensions is product. That's something that certainly you could do without too much analysis using traditional techniques. You've got region, okay, that's a couple of different dimensions. Again, something that can be done pretty easily with traditional techniques. But now you're adding actual and projected, so it adds a little bit more complexity to it. Now you're talking about 3 different dimensions. So you can really start to represent more complex pieces of data for comparison purposes if you want to. And like I said, you can actually add more dimensions which you can't visually represent on a piece of paper or on a screen. So for example, you could slice up these individual boxes. So inside of those boxes, that's probably about as far as you could go visually, because like I said, mathematically you can slice it up even more. Data mining is more discovery driven than OLAP. With OLAP, you have a question. You wanted to know how many you sold in a particular month, in a particular region, compared to projected versus actuals, or comparing those two. You had a question in mind. With data mining, you don't have a question in mind, you just want to see what's there. And you do it for a number of different reasons. You might want to see what associations you have between different entities or different pieces of data. You might want to identify sequences. How often, if X occurs, how often does Y occur? Maybe you want to find that. If we get this kind of customer and we provide this kind of sales promotion, how often do we get a purchase? That type of thing. Classification. So we have groups identified. How are people? How many people are we actually fill those classifications? Versus clustering. We don't know how many groups there are. Identify them for us. So exploratory factor analysis. And then forecasting. Something that data mining allows us to do. Allows us to find patterns in customer data that we're not really looking for. We kind of identify those patterns after the fact and provide some kind of rationale for why they occur. There's some argument as to how effective that is, but businesses spend a lot of money on it, so my suggestion with respect to that, if you don't like computers a lot, if you like numbers, get good at statistics, because you can make a lot of money in data mining. Predictive analysis uses data mining techniques, historical data, and assumptions about future conditions to predict outcomes of events. Same kind of thing. Using hard data, historical data, to be able to make predictions using regressions, multivariate regressions, things like that, or regressions, to be able to make predictions based on historical data. It's exactly that. It's a prediction. It's not always going to be right, so be aware of that. But certainly it gives you more insight than you would have otherwise. And then text mining. They spend a little bit of time in the text on this, and this is probably a pretty good thing to learn a little bit more about. These other techniques that we've talked about so far are assuming we've already got data. We've got data in a form that's easy to analyze. Sales, number of products, product numbers, things that we can easily analyze, add, multiply, things like that. With text mining, we've got unstructured data. What do we mean by unstructured data? Other than the example that's on the screen.
Random words through text, or through emails, or through search engines, or through
Yeah, things that come in. The example they give are emails. But don't companies also get calls? You ever call your bank or whatever, and you get that recording that says this call may be monitored for quality assurance purposes? They're recording that. That's data. It's audio data, but it's data. They can transcribe that either manually or automatically, and it's data. It's not structured. They don't know exactly what's going to go on in that conversation, but they can use that for for analysis. And that's what they're talking about when they talk about unstructured data. And text mining allows organizations to look at that information and start to draw some conclusions from it. At this point, I wanted to take a look at this. We've only got 3 groups tonight, but it is what it is. So I wanted to stop for about 10 minutes, take a look at this one, and we'll just do these first 3. I'll talk a little bit about the last one. So same thing as we did last week, 1, 2, 3. All right, so what did you guys come up with? So for the first one, group 1, what challenges does the increase in unstructured data present for businesses?
Time increase, the personnel to go through it all, and also
Can they go through it all?
Yeah, and possibilities of going through it all and having developed or utilized software like they were talking about in the thing.
That is the challenge. Without software like that, you can't realistically go through it all.
Yeah.
You could, but the problem is no longer a problem. Your customers all left before you figured out what the problem was if you had to go through it manually.
Well, the other thing is, how would you identify, I mean, there's got to be a common concept or a common keyword or something that would trigger it to be that, and different groups use different phraseology, so how do you...
Yeah, it depends on the software that actually does this. The text mining software has actually gotten very competitive over the last few years in terms of not only doing keyword searches, but doing much more in terms of being able to identify the structure of words, the structures of sentences, to the point that they can identify a person that's writing. That a person submits enough in writing, they can that a package can identify you as an individual. They're that good. Obviously, you can't take a few words and do that, but you get enough over time, you can identify that this person is writing the same thing over and over again, and is visiting this site and leaving stuff, and visiting this site and leaving stuff, visiting that site and leaving stuff. So the capabilities are much better than what they once were. It's not just keyword searches, but certainly even just doing keywords would start to give you some feedback. And if you have your site and you're getting feedback based on the keywords search that every day your website sucks, and that's the keyword, and it's 10 every day for a month, and then all of a sudden it's 500, something probably happened. So that maybe you need to take a little bit of a closer look at those emails or blogs or whatever they happen to be. Certainly it is a challenge because it's not structured data. It's difficult to analyze that, but there is a lot of really, really rich data in unstructured data that really allows a company to get to the root of a problem. So these data analysis approaches that allow you to capture that and analyze it and make decisions based off of it really give you a lot of potential in terms of being able to improve your company, improve your image, improve your processes. So that's good. Group 2, how does text mining improve decision making?
It helps the company have a better picture of their customers' attitudes in a quicker time, so they have access to the data to make real-time decisions with large volumes of data coming in through email. They're able to filter through and make decisions that help their customer satisfaction and profitability.
Who did not read the chapter? Anybody read the JetBlue example? I mean, I'm not a big JetBlue, I don't have stock in them or anything like that, but it was a good example. They had the problem a few years ago when when we had bad snowstorms and people were sitting on the tarmacs for hours, and people testifying before Congress and doing textual analysis with respect to all the complaints that were coming in. They simply couldn't look at all the complaints. I mean, they just couldn't. They'd be a data analysis company, not an airline. But through textual analysis, they were able to go out and identify a set of passenger rights that they felt were reasonable responses based on the complaints that they were getting. So they're able to address these all these complaints, the major concepts of these complaints with this customer bill of rights without actually having to go through every single complaint and look at it in detail. You simply can't do that. So it allows you to really kind of get a look and feel much more quickly than you otherwise could. Group 3, what kinds of companies are most likely to benefit from text mining software?
Fast food, hotels, theme parks, and it also mentioned law enforcement or government agencies in the little case. And we were thinking that's probably because, you know, they can use it to go through all of their tips on crimes and everything like that. But basically any company that deals with customer satisfaction or a service industry.
That's it. That's the common factor. The ones that are dealing directly with the customer in some fashion. You look at electronics companies, for example, an electronics manufacturer makes TVs. They don't see the customer directly. Nobody buys a Sony TV from Sony. You just don't. And fortunately, Sony won't even make TVs, but that's a different issue. They go through retailers. That's who you deal with. You deal with Best Buy. You deal with, you know, whoever the latest big box store is. But if you're somebody like Best Buy, you use this because you deal directly with the customer. You can get a lot of valuable information from it. In what ways could text mining potentially lead to the erosion of personal information and privacy? Personal information privacy. You know, if somebody simply puts one thing in a piece of text, we talked about unstructured data a little bit ago. Unstructured data comes in all different places, blogs and these voicemails and all those types of things. Facebook, another place, just a lot of information that goes there. Well, let's face it, in certain environments, we provide all kinds of information. It may be a complaint about a product which may be really valuable to American Airlines or Best Buy or whoever. They may be really interested in that. But at the same time, you may have a tendency to post information about other things on Facebook, for example, about other topics that you don't necessarily want them analyzing. So maybe you're sharing too much by doing some of that. So you do have that potential for a loss of information privacy when this stuff gets opened up for everybody to be able to analyze so much data so quickly and so easily. So that's good. Any questions over any of that? I like doing those because it kind of changes things up a little bit and hopefully provokes a little deeper thought. Web mining, discovery and analysis of useful patterns and information from the web. Basically the same thing. The only difference is we're moving it onto the internet, we're moving it onto the web to analyze those blogs that everybody likes to have anymore. Everybody likes to do, to evaluate the Facebook and MySpace and all the various things that people do. Certainly something like Angie's List would be a great place for organizations to look at. That's where people write recommendations, write complaints. If you're a company that provides a service that's likely to be on there, you want that information because you can either address the complaints or you can try to improve your business processes. Web content mining, knowledge extracted from content of web pages. Web structure mining, links to and from a web page. That gives you information. If you link out to other web pages a lot, you probably have a pretty rich page. You're providing a service to individuals. You're helping them to locate valuable documents and other web pages. If you got a lot of links coming in, other people think you've got valuable content, so that gives you information. Web usage mining, stuff that we really don't have any control over. If you visit a web page, their server's logging what you do, just because it's their server. They have that right. It logs how long you stay on a web page. It logs what page you came from when you went to the web page. It logs what the last page was that you were on when you're on their website, and what pages you're on in between, so where you're going from one page to the next. So there's a lot of information that can start to gather about what's going on their website. If they have certain pages that get visited a lot, that have a lot of time spent on them, that says those pages are probably a little bit more valuable. That's good content. That gives them information about the other pages that aren't visited as much, that don't have as much time spent on them. Now you have to be careful with that type of analysis because there's certain things that have changed. What's changed over the last few years in terms of websites? content that we put on them.
Wikis, a lot of it's user created.
Yeah, but where I was going was video. We put video on web pages. You have to spend time on the web page now. You may not be picking up on anything else on that web page because you're just watching the video. So website analysis in terms of time, you have to be aware of the content that you're putting on the page. Again, just because you spend 10 minutes on a page doesn't necessarily you got 10 minutes worth of looking at their ads that they put on that page. You're busy watching the video. Database in the web. Many companies use web to make some internal databases available to customers and partners. That's a great thing about browsers. Again, we've talked about this before. Everybody knows how to use a browser. You can even get a CEO to use a browser because they know how to get on there and do certain things. So you can make some of these databases with all the various complex queries much more user-friendly. It allows them to take advantage of these databases and the information that you can get back out because you can put it on the web and have it accessed through a browser. All you need is a web server, some type of middleware, something that's going to allow the web server to translate user parameters into an SQL query of some kind, and then the database server itself. So the advantages, what we were just talking about, ease of use, web interface requires almost no modification, if any at all, to the database server. And it's usually pretty inexpensive to add a web interface to the system. So, you know, when I say pretty inexpensive, it's free unless you just really want to give somebody money. So that's kind of a model of that whole process. Your client with a web browser, accessing it through the cloud, a web server. This is a multi-tiered system. You've got some kind of an application server, some kind of middleware that's performing the translation between the database, between the web server and the database server. And then the database itself may be on the database server. It may be a separate hard drive or something like that. Now, managing data resources. This is kind of how we started out class, talking about the data that goes into the database. If the data is not any good, all your reports are worthless. Maybe not worthless, but they're not worth nearly as much. That's why you get those duplicate things in the mail, name slightly misspelled, or you used your middle initial on an application at one point and not at another place, so now you get two. So you can establish various rules and procedures and ways for handling data to help improve that issue, help to improve the data that's going into your database. You've got database or data administration, data governance, and then database administration. Data administration, where the firm function is a firm function responsible for specific policies and procedures to manage data. How are you going to manage data? How often is it going to be backed up? Who can enter data? What are the procedures for entering data? Things like that. Data governance. This falls within data governance. You know, data governance is more encompassing in terms of developing policies and processes for managing the availability. So when is data going to be available? How often does it need to be available? Usability, integrity, security of enterprise data, especially as it relates to government regulations. So it's really looking at data from a larger perspective of saying, you know, if you're, again, going back to what we talked about earlier, if you're in the medical profession and you have to deal with HIPAA, you know, where is this data going to be made available? Are we going to allow access to this data on the internet to certain customers? Because if we do, it's not that we can't, but if we do, we have to take certain security precautions. How are we going to encrypt this data now? How are we going to allow authentication for somebody that's remote to access the data? We've got to make sure that all that stuff is going to be secure so that we can comply with those government regulations. And then database administration, defining, organizing, implementing, maintaining database, performed by database design and management group. The database administration is an ongoing thing. It's somebody that designs the database, it gets implemented. It doesn't just stop at that point. The database administrator routinely goes in to run ad hoc queries for people, to back up data for people, to optimize the database periodically, things like that to make sure that the database continues to function as it's supposed to. Then they talk about ensuring data quality. More than 25% of critical data in Fortune 1000 company databases are inaccurate or incomplete. 25%. Think about all the storage that's just being wasted. Most data quality problems stem from faulty input. But we talked about earlier, if you can have the computer automatically input some of those foreign keys for you, you're not going to have a lot of that problem. But when we start typing, we make mistakes. We look up. We get so used to that 10-key punch that every now and then we make a mistake. We don't even notice it. We just keep right on going. So a lot of it is just from us inputting stuff incorrectly. Before your new databases are in place, you need to identify and correct faulty data, because if you don't, you're just adding more bad data on top of bad data. And establish better routines for editing data once the database is in operation. So how are you going to go about cleansing it? That's what we'll talk about here in just a second. One of the things you can do is do a data quality audit, and that's basically just how are we going to find whether or not our data is bad. We need to audit our data and determine. You can do survey samples, which is just doing a sample. Let's pick 10 records at random or 50 records at random and look at them. Are the records complete? Are all the names in the right fields, the last names in the last name field, the address is complete, the phone number's there? You can do an audit that way. I would contend it needs to be a pretty substantial sample, or you need to do all of it, because one of the concepts about this is that if you have a single record that is false, you don't know how many records you have that are false at that point. If there's one that has bad data in it, you really don't know how bad the rest of your data is. So it's kind of the rotten apple spoils the barrel thing. You really, I think, need to be more prudent in terms of looking at more of your data. Another thing you can do is you can survey your end users for perceptions of quality. My wife likes to say perception is reality. Political science major figures. There is a degree of legitimacy to that. If they don't care that they get 2 things in the mail with name misspelled, that's fine. And then if you find issues, you can go through a process that's referred to as data cleansing. You can either manually do it, go in and make corrections. Depends on how valuable your data is. If you're a financial firm and you only have a few hundred customers, maybe it's worthwhile calling up each individual customer and talking to them and saying, okay, we think we've got an issue here. Let's make sure we have the right information and get it corrected that way. Or if you're a really large corporation, you've got thousands, tens of thousands, hundreds of thousands of customers, maybe you go a software approach that goes in and tries to validate, for example, an address relative to an area code on the phone number relative to a zip code in the address, things like that, things that can help to try to automate some of that process. The idea is to enforce consistency among different sets of data from separate information systems, whether those were developed inside the same company or it's occurred because of mergers and acquisitions. It doesn't really matter. It's whatever that new firm's data requirements are. And then the last one, which I'd encourage you to go ahead and read through, it talks about credit bureau errors. If you haven't gone through this, you probably will at some point. There are 3 major credit reporting bureaus. They have 3 different credit reports for you, and there's probably some overlap in terms of they have most of your names spelled the same way, but they are definitely different. So take a look at that one. It's probably somewhat valuable just in terms of learning about how the credit bureaus operate. So that's all I have for you this evening. You have a question?
I find it really interesting that they don't talk about implementing like restrictions on fields. My dad is a database administrator, and a lot of what he does is setting up forms to input the data in the first place and also correcting it. And he works for a bigger company, well, not a huge company, but a cell phone company, and 99% of everything is automated, because if you don't, it's impossible to have.
That's right. They do mention it in the chapter, but it's very briefly, and they just barely touch on it. And I agree. I think they should talk about it more. When we were talking about the database, and they gave the example of the Access database, it gave you a form that you could fill out. You could make a piece of data required. You could validate the data. Yeah. And data validation is a really big deal. And there's a number of different levels that you can validate. You can validate at the database level. saying, and there's only certain things you can do at that point. You can make a piece of data required. You have to have a name. You have to have an address or something like that. You can also address it programmatically so that before you can code it into whatever language that you happen to be using, you can code it into the web page that you're using, however you want to do it, something that's separate of the database. That as somebody leaves the form, those fields have to be formed out. They have to be filled out. They have to be the right format. You have programmatically, you have more control over what's going into the database than you do at the database level. But absolutely, data validation is a huge deal, and we're much better about that today than what we were way back when. Way back when, you had a lot of not only data issues related to data validation, but you had a lot of security issues related to it as well, because that's how you ended up with buffer overruns, where you would type in a field, type in data that was too big for a field to be able to handle, and now all of a sudden it was a security breach. You had something?
I was going to say, but I wonder, it seemed like in the old days we had to work to maintain the data effectively, so because storage was a problem. And
Yeah.
now that storage is so cheap, it seems like we keep everything, whether it's good or not.
Yeah, and like I was just saying, I think we do a much better job of handling data validation today than what we once did. Part of the problem comes in that we still have these vast databases that we don't want to just get rid of all this information that we've been collecting for years and years and years. We want to use it, but the data is not always, good. Traditionally, when we didn't have nearly as much data, yeah, it was kind of a closing the door behind the close of our door after the horse is out. Of let's go back and fix the data after we've already collected it. Well, that's expensive. It's a lot cheaper to do it when you're first collecting the data, but you've got to collect it properly to begin with to minimize your costs. Anything else? Good questions. Okay, doke. Have a good evening. I do want to let me announce this real quick. I don't know if it's in the syllabus or not. I will go back and look at it to be sure, but as a formal announcement, and I'll put it out on Blackboard, you are supposed to be present in class for the quizzes. Just to make that clear, I don't think it's a problem. Everybody's here, so.
Some people took it.
Yes, I noticed 2 people took it, and so I will put that as an announcement on Blackboard, and I will lock down the quizzes from now on so that they can only be taken in class. So they're set up right now, they can only be taken from 6 to 9, but I'll lock them down so they can only be taken in class. So just so it's fair for everybody. So thank you much, and have a good one.